I would be more afraid that they would become more like invasive species and like destroy habitat.
You should be good with the air. Hey everyone! Thank you all for coming. This is the final presentation in the 2015-2016 Ag 64 Brown Bag series. And today we have Laura DiPietro from the Agency of Agriculture, who's going to be talking about Vermont's subsurface tile drainage interim report. So with that, I'm going to turn it right over to Laura.
Great. So this is recording, and folks can hear me okay?
Yep. Yep.
Well, thank you, and welcome to those in the room. So the presentation today is really just an overview of an interim tile drainage report that the Agency of Ag and the Agency of Natural Resources did. It's available on our website, and there's printed copies as well that are available. I believe I saw them on the desk out in the hallway. It's a general report that was required by the legislature, and so this presentation pretty much summarizes much of what's in that report. So the history of tile drainage, as you can see, it started back in the 1830s, and it was a very different type of system than we have today. You know, lots of real close contact with soil, digging in trenches, laying clay pipe, and a lot of this work, starting in the 1930s, there's a lot of interest in making sure we had better crop productivity. We had the Dust Bowl. We really had a national presence of interest of making sure that crop production was successful. And that led to, in at least the United States, cost sharing of installation of tile drainage by the U.S. Department of Agriculture. That no longer happens in any place that I know of in the United States. It stopped back in the 80s. And the only type of installations you might see that might be cost shared might be when you install a conservation practice and then trying to drain the water around it to make sure that it is well managed and doesn't lift. And if any of you that live in Vermont and have done anything in your front yard, you know that clay soils can be a real challenge, and drainage is important to make sure whatever garden bed or whatever you put in is not crooked the next year. So that kind of concept. That's the only drainage that I've seen that is installed is mostly for foundational purposes. But there's a long history and relationship there that I think is important to understand, that we promoted this practice very much in this country until just recently as 30 years ago. And the pattern in installation changes that have occurred today, I'll show you a slide that gives some sense of what today looks like if you're not familiar with it. But again, that slide I just showed was the historic clay laid tile, and they were very random. They were laid where it was wet. You can imagine that level of manual labor. You're not going to go in places that it isn't as cost effective or the time isn't as beneficial. And so they were very random. They were shallower. As you can imagine, equipment today can make it go much deeper. Then when you're digging a shovel, you sort of probably just choose the level of that's good enough. It really was hard work. But it was in low swales, and now they're looking at more systematically throughout an entire field and installing it as a more widespread infrastructure because of the economic and crop productivity benefits that they get from it. And we'll cover some of those in this presentation. Here's a picture of what today is commonly installed when a tile installer does this type of work. And just for reference, the equipment that is used to install this type of tile, it's very expensive. It's not owned by a broad, every farmer. There are typically some contractors who own this type of equipment at this point in the state. A lot of New York work is actually brought over and done in Vermont. There's contractors from New York that work here. And over in New York, there's a great deal of tile as well. If you've ever driven up outside of Plattsburgh, there's a lot of flat land, and a lot of that is managed under the same system. But it's basically, as you can see in this photo illustration, is they're laid straight, and then there's a header tile, which also is a clean out at some level as well to make sure that you can access and clean it out. One of the major challenges that I've seen just in my experience with tiles is rodents getting in and chewing through the piping and plugging it up, and then you've got to go in and install and maintain it. And that's where, if you've ever walked through a field and you see kind of a hole in the field and it seems kind of random, it's probably because there's a tile underneath there that has failed, essentially due to a rodent getting in. So there is a great deal of management that goes on. But then you can see the outlet of it typically goes into a ditch, or it could go into a stream, and that's because of the natural flow and trying to remove the water. The idea around tile isn't as much to drain the surface water. It is more to lower the groundwater table. So if you can imagine, if you're trying to work in your garden and it's wet there, lowering what's always wet is really what the goal is, not necessarily focused on trying to deal with the precipitation. Naturally it does, but it's really lowering sort of that soil layer that might be a perched water table. So even in some of these sites, you might see in times of the year where it hasn't rained, it's still flowing a tile outlet, and that's because it's the groundwater that is essentially moving through the system. And results we've seen from tile drainage samples is that, those base flows, even under natural conditions, not in agriculture, or even in agriculture, there's sort of a residual phosphorus level that is existent in base flow groundwater that has, a phosphorus level. It's low, but it is existent. So in 2012, there's an ag census that gets sent out every year. But in 2012 was the first year, actually every couple years, sorry. In 2012 was the first year they asked about tile drainage specifically. And so this is the first year that we really have data on the presence of tile. And albeit the census data is only as good as the respondents, right? If anyone's ever done a survey, you know the challenge of that. But it does give some insight into what's going on in Vermont. And if you take a step back and think of a bigger perspective, and at least in the experience I've had, we go over into the Connecticut River and talk to folks about tile, and they're not doing tile. They've got great sandy soils in the Connecticut River. It's not something that they're working with. But when you look at Lake Champlain and the historic, change of a marine clay that is present in some of the soils in the agricultural fields, you can see why the presence of tile is increased in that area or region of the state versus other regions of the state. So in the whole, when you think of Vermont, when it says 4.8% of the fields are tile drained, that makes sense when you look at the whole. The Agency of Ag did a more focused project last year on Jewett Brook and St. Albans Bay to understand how much tile drainage might be there, and that was just a presence absence. If I saw the photo that I showed, you can see sometimes when you take an aerial photo the presence or absence of tile. You may not be able to draw the whole system due to moisture in the soil, but you can at least tell that there is tile drainage in that field. And so when we looked at some of these smaller watersheds, almost 70% of the fields had presence of tile. And again, some of it may have just been a few lines here or there. Some of it may have been more system-wide, every 30 or 50 feet tile drainage. So in some areas it's more intensive than in others, but as a whole in the state there is not a significant amount of tile drainage. And where there is tile drainage, it's pretty clear that it has pretty much been maximized to date, and I think that that's because you've had 50 plus years of drainage installation going on, and these soils have always been these types of soils. They haven't changed. When you look at what type of agriculture in Vermont is using tile, you can, the numbers line up to what we see and what we expect, which is the predominant use is in dairy, milk production. So with that is also, hay farming or other crop farming utilizing hay. So it could be horse pastures or other beef animals that utilize hay. So livestock industry is really where it's focused as far as the use. Not to say, though, that these other types of agriculture do not use it, and it has a really great benefit for them in terms of crop productivity. Some of all those other categories tend to be higher price commodities at the unit, so the scale might be a lot smaller, but the benefit there is probably maybe 2 or 3-fold to those farms. So some of the benefits, I've kept mentioning some of them. As you can imagine, as you put tile in a field, you're going to increase the amount of air that can get into that field, which makes the soil warmer, which makes the biological activity able to increase, which then they themselves, as biological activity, can change the soil properties in the sense of making it a healthier soil, more macropores, more ability to retain water, also more ability to reduce when pests are an issue. So if a soil is really compacted, as you can imagine, which if some soils were not drained and heavy equipment were put on them, which in the current dairy industry, if we use that as an example, the equipment's pretty heavy. And so if your soils are wet and you put heavy equipment on it, you only further compact it, which can then have negative impacts on managing pest cycles and managing other activities like that. Or if the soil has more air, can breathe, can be healthier, you obviously reduce the compaction, but you also reduce the pest cycles that can exist, or disease cycles as well. And then naturally, as you can imagine, it increases crop yield. Plants need soil, air, and water. And if you put all those things together, you have better crop productivity. So getting that air in there is really the key factor there that increases that. And then, for some fields where if they are wet and there's a year where there is a significant amount of rain, there may be a crop loss, and they may be back out there replanting if it weren't tiled, say for instance, back on the soil again, doing additional nutrient applications potentially, typically for nitrogen when there's additional rain. With tile drainage, you may be able to reduce some of those additional activities on the field to make up for when there is poor weather. So there is an efficiency in labor and in time from the agricultural perspective of having a good soil that can manage through any of the longer periods of rain during sensitive times of year while you're trying to grow a crop. I know as a garden farmer, I failed horribly in some of these wet seasons and had to replant, and that kind of concept, if you can think about it. On the environmental side, as I mentioned, if you have a good, healthy soil, you can increase the amount of water that's in it. In some instances, if you had a soil that was prone to surface runoff and water is able to go down now instead of straight off, you can reduce the amount of surface erosion because as water picks up speed, it picks up sediment, and so you get erosion and thereby nutrient losses that way. And then the peak flows. So when a storm event happens, if most of your water is going off the surface, you're obviously going to get that water quicker to the watershed, right, to the river and the lake. But if it can go through the soil profile effectively, it can slow down those peak volumes. But what I'll show you on this next slide, somewhere in here on the hydrology side, the downside is if you have clays with giant cracks in them, that could also then have the opposite result of increasing the speed that it goes through. I think in some level there's the differential of it could increase the speed, but really what you see is the fact of the matter is that 90% of the hydrology, or the peak flow, will drain through the outlet. So they're seeing that high volumes of the water go through, but it may take slower. So the curves, if that makes any sense, may be off. So if a rain event were to occur and there's no tile drainage, the speed at which it goes off can vary, but you can either have it go much faster or you can have it more of the total go there, but it may take longer for it to get there. So before, some might have gone off, some might have gone in. Now with tile, it all probably goes down, but the speed that it gets to it may be variable, if that makes sense. But more of it, they're seeing that the higher total volume might be going through, but it isn't necessarily all at once. So those preferential pathways are a really important thing in breaking them up. And it's something in Vermont that farmers and UVM Extension are trying to learn and understand a little bit more about in terms of, do you do deeper plowing to try and break this up? We've tried to push, and if you've paid attention to the Midwest at all, we've tried to say, hey, no-till might be a good choice for tile drain fields. It might be, but if you've got these giant cracks and not breaking them up, then it may not be. And so this is all just recent information that's come out in the last few years. And I'll just say one thing. I like to think I'm not that old, but when I did my master's thesis, which was, 13 or 15 years ago, we thought phosphorus did not leach through soils. It just didn't. And that was everything we focused on. And every research paper and literature article we ever looked at, it was about total phosphorus or soluble phosphorus and managing erosion. And it's just in the last 5 years that people have really realized that this soluble phosphorus is really moving off of agricultural fields at a rate that we didn't understand. And right now we've got some EduField studies set up. Well, NRCS has supported them through their EduField monitoring program. And what we've seen from these preliminary results is that higher volumes of soluble phosphorus, even on the surface, are coming off than we ever thought that there were. And so this nature of soluble phosphorus is definitely changing. Across the country, I've read articles. They're seeing similar results. And Andrew Sharpley is a really big phosphorus scientist, and he's recognizing it as well and just trying to understand why. Why did we not understand this a number of years ago? So this is all emerging science in a way, and trying to understand how to manage around it, because we're pretty good at understanding how to manage erosion, but soluble is a whole other issue to deal with in terms of retainment within the soil profile. So on the nutrient loss output side, you can imagine if management practices, from what we've seen, really play a role, right? If you're going to put any nutrient down on the soil and it rains, you can imagine if you've got cracks, you've got a higher volume coming out as far as concentration of phosphorus in your tile drain. However, if it's a number of weeks until that rain event occurs, that number is significantly reduced because the soil microbes have taken up that nutrient and utilized it as well as the crop and made it more stable before the rain event. And so trying to understand how to manage around these aspects and make sure that farmers understand how and when to manage fields appropriately is another area we're working on, and I'll show you that. But again, it takes more research and data on our part to really give them good advice on how to manage around this. But, as I said in the bottom here, 17 to 41% of total phosphorus and 16 to 72% of dissolved reactive phosphorus, which is essentially soluble phosphorus, can go through these outlets. So it can vary, and it can be substantial. That's a great amount of soluble phosphorus, 72%. And I think most of us at this point have recognized that soluble phosphorus is what is readily available for plants and also for algae or other organisms that want to uptake it. So some of the management practices, we mentioned manure application, for instance, and management thereof. One of the tools that we have in Vermont as far as nutrient management planning, which all medium and large farms have to have a nutrient management plan, and with the RAPs, there's a new set of small farms which would be required to have certification and also have a 590 federal standard nutrient management plan. One of the tools in that plan require you to run a phosphorus index, which is a risk tool that identifies proximity to water, how your erosion is, but it doesn't have, it was built when I was in grad school, worked on it, to deal with, it doesn't have anything about tile drainage in it, because again, no one recognized that was an issue. So UVM Extension at this point is working on revising that and using modeling tools that exist and trying to tailor them to Vermont to try and incorporate tile drainage into the phosphorus index. So then as a regulatory requirement on these farms, that would be considered as far as in their nutrient management plan on how to manage on those fields. So that's something underway now that's actually funded by NRCS through a CIG grant. And then other research that we don't know enough about, there's going to be a literature review that'll give some information, but we don't have any Vermont research set up at the moment to look at this. Is specifically when you change management on a field, what does that relate to and an impact as far as a change in the outcome of tile drainage or even surface drainage? What we've all been talking about as a partnership is we really need to understand what's coming off the top of the land and the tile drainage as a whole. So like the mass of that whole field versus we've looked at what comes off the surface, but we haven't been able to capture an entire field and really collect, which any of you who do field work, the challenges of trying to capture everything and set up a good statistical evaluation site that you can work with. But we are moving in that direction. There are funds available to do this work. USDA has worked really hard to do that. And the farmers have stepped up to do some of this work. I think one of the challenges is that all of this research right now in the USDA and how it's structured at the national level is it comes out of a farmer's money that would be available to them for doing conservation projects. So if they need to do something to meet, to improve water quality on their farm, aside from research, it's going to cut out of that funding. And this is not very low-cost research, as you can imagine. It's a significant cost, and it really reduces the amount of money available to them. So some structural practices that we're looking at in fields, because there's the management, right? You can deal with how you manage your nutrients, how you grow your crops, that kind of thing on your field. But then there's also structural things that we're trying to look at. And across the country, nitrogen's a big issue with the Gulf of Mexico. And they've done a lot of work, and they've figured out how to manage some of these practices structurally to filter out nitrates. We've taken some of these technologies and concepts because there isn't a great, we can't just go to a manual and find a BMP for phosphorus reduction for tile drains. It doesn't exist right now on a national level. And so we're trying to come up with it at this point. And basically, these diagrams, the first one here is a drainage control structure, which Minor Institute is an agricultural institute over in New York. And they run a dairy farm. It's very similar to the type of systems that are put in Vermont today and the type of industry that's being utilized on the land. And they also have a NRCS CIG, it's a Conservation Innovation Grant to do this work. And basically, they also use these systems in the Midwest. It blocks the water up. And so if you can imagine in Vermont, it gives it time to sort of biological process in the system before you then release it. So if you were to use Vermont as an example, and I think I have a slide on the next that shows you a picture of this, so remember this and then watch the visual, is that basically in the fall, if we're using a dairy farm in, say, a cornfield, right, and they're done, they've harvested their crop, they can shut the valves, because these valves, they have different plates on them, and you can set the level of what you want the water table to be. They can shut it off all winter, because if the soils are wet, you're not trying to grow a crop at that time. Certainly with cover cropping, this might be more of a challenge, and that's we're requiring cover cropping in some areas, and then suggesting you might do that. So we need to figure out how these two things go together. But you could then have that go all the way through into the spring, and before you're ready for getting back out there to do work, lower those and lower the table, and then hopefully, if you've ever looked at any of the data for the water data, these shoulder seasons can be some of the toughest seasons where there are no crops being grown and there are losses. And so if we could maybe hold back those losses by implementing these kinds of structures. And they're relatively cheap, they're relatively easy to manage. Everything has a challenge with it as far as management, but they're not super high tech, they're not electronic, that kind of thing. So that's something that Minor Institute is studying, and they're seeing pretty good results with it at this point. So we'll keep watching that. And that's another CIG. The nice thing about it, it's a multi-year project, which is really helpful, because any of you who do field research know that 1 year is never the same as the next in Vermont. It can go from drought to complete saturation. And so really understanding how systems function throughout those different weather patterns are really important. The picture on the bottom there is a site where, again, this one's actually an this is a CIG grant, apologize, as well. And we've basically, UVM Extension worked to review a bunch of different soil media. So when I say media, I mean like a treatment material, to figure out what kind of media could you put at the end of a tile system to effectively treat and capture phosphorus so that it can be removed before it keeps going into the waterway. And I forget the number, but I feel like they at least looked at 8 different materials. And the goal of trying to look at these materials is, they can't gunk up. They can't just stop water, because then it's going to defeat the whole purpose and you're going to cause structural failure. So water has to be able to go through them, which is important in the sense that some of the materials that they tested immediately, they just, they seemed like they were rocky material, but you add water to them and they just dissolved. So those materials obviously wouldn't work. But the other goal is to make sure that the retention time cannot be really long, right? So water needs to move through and it needs to move out if it's going to be effectively working. And you need a good, quick retention time ability to take out the phosphorus. So some materials take a longer time to interact with the soil-water interface and take the phosphorus out and bind it. Some can be very quick and can do that job more effectively. And so trying to understand how much retention time do you need and how much treatment time do you get for that. So UVM did all these benchtop studies to take a look at what materials would work best. And 2 materials were selected out of all of that. One of them is water treatment residuals, which are used in the drinking water plant as sort of the materials left after they filter the water. And it's basically more like an alum product. So that one's being utilized, and then the other one is a limestone. And the goal was to find things that are local and to find things that don't have another use, right, so that it could be a repurposed item. And right now, preliminary results are showing that the water treatment, both are successful. The water treatment residuals are more successful because of the alum binding connection. And so we will continue to do this stuff on this particular site and looking for more sites to do this. But you can see this example is a concrete ledge box. And keep that in mind, because the reason we put that in place was, what if there were an issue? And research projects, you build things a little bit different so that you can manage and work around the research project. And then soil amendments, there's not a photo there, but just this idea of, some of the historic phosphorus levels in soils in Vermont are from past management practices. There was a time where the USDA was promoting using triple superphosphate. These inputs have all gone onto these farms, and the place where it all ends up is in the soil. And so today, these farmers now, coming under new regulations and looking at new data and information and technologies, have this challenge that they've got to figure out how to manage. And so one of the things that we have looked at is, could we use like water treatment residuals as an example? Instead of putting them in a box, could you put them on the field? And I know Don Meals has done a lot of research on this, and it's shown that it can be effective. And I think understanding the sideboards of how you work around that management, because you don't want to protect a field in terms of binding the phosphorus in the field, if it has a negative impact on the cropping. But also you can't then just say, well, it's okay to keep with your normal nutrient regime, right? The goal really should be to reduce the amount of nutrients, and so how to manage that effectively. The picture on the right is some potential research. We just haven't engaged in it in Vermont. And the idea is instead of the pipe going straight to the ditch, have it go lateral in that buffer and really have a way to then let it go and soak through and just have more contact time with the soil in these buffers. We require 25-foot buffers along all surface waters, and a new regulation that is hopefully in place come September is that all ditches will have to have at least a 10-foot buffer. So there will be places where we could use those buffers a little more effectively as a nutrient sink. So here's a picture, and just to show you an example of some of the challenges that come with trying to do some of this work at the end of the pipe. Now certainly we're looking at the bigger picture of the sources coming in. You have to. You can't just look at the end of the pipe. So looking at, feed coming in, there's a lot of work that EVM Extension is trying to look at on reducing feed inputs, whether the balance of the nutrient management plan is effective, and whether that nutrients need to be exported off. So we're working on these type of bigger picture things. But if this example we run through is just some of the real challenges in the field that we've seen at the end of the pipe trying to do the work we've been doing. Whoa. These are my high-tech visuals. So if you imagine this is filled with water, right? There's a high flow event, the ditch fills with water, that drainage pipe goes underwater. The treatment system, the green box, would normally be farther back. It wouldn't be that close to the field, but the photo didn't give me the opportunity to have more cornland to get into. But it probably would be outside of the buffer, but right at the back end of it. A couple of problems that we have is the slope of that tile is so flat right there that to get enough head to push the water through the material is really challenging. The other issue is when that water is up that high, you're then treating incoming water from the lake or a system of drainage ditches, which then you're burning out your media potentially, right? You're not utilizing that media that's invested for that system to treat the incoming from the system. You're treating broad, and when these events happen, you can imagine the stream banks and everything are turned up, and there's a lot more phosphorus in that water that you're then treating through that system. So we don't know what that means for the longevity of some of these materials either, and that's one thing really needed for longer term research is if we figure out what the right media is, how long does it last? Can it recharge itself? What do we do with it afterwards? So those are the kind of things, and why we're trying to pick materials that can be reutilized in a way, and not trying to pick things that might be considered, for instance, like solid waste, which are just heavy metal, basically, to pull phosphorus out. But the other thing is that the proximity to these structures, if they are structures in nature, are going to be close to stream banks or ditches, and that's not good. We don't want to put more infrastructure in a place that might be sensitive or challenged in terms of erosion. We don't want people saying, I need to riprap to protect a tile drainage structure. That's I think in total disconnect of everywhere where everyone has said, rivers need to be a little more natural where they can be, and so then increasing infrastructure in those areas is not our goal. And so trying to figure out how do we build these to make them not so infrastructure heavy. And I'll show you an image of that in a second. But the next question that I think that is really challenged in what we've learned so far is, here's a diagram or an image showing different tile drainage. I think everyone, you can see the tile, correct, in the lines? Well, so those two tiles that are circled in red, those are pretty small watersheds. Each one of them is draining a pretty small watershed. In theory, I haven't done the watershed mapping to figure it all out, but just going on a visual trying to understand. When you compare it to that system, which has multiple larger tile lines going into a cross line with one outlet. So the watershed size is very different. But when you're standing there in the field, and if you don't have imagery such as this, and even that top one, there may be other tiles that you're not quite seeing or being drained into that particular outlet. Identifying the size of the watershed is really challenging. And this is something that DEC and Ag are going to try and work to figure out how do you identify, i.e. map, where these systems are, because in order to do research, in order to size how much treatment material might you need to do this. Because remember, if in some watersheds there's already 70% of the fields tiled, there's already a great deal of work that needs to be done, right? And so trying to figure out how big these watersheds are really important, because you can quickly overtop a system that you design. So one system we were looking at, I think it's treating about 30 acres, and it's overwhelmed itself a few times, because to understand throughout the year what the total flow out of that might be, you can run calculations, but you really don't know if there's giant cracks. The variation in that flow could be pretty great. And the few samples you might take to figure out as you're learning about your study site is not over a 2-year period. It's over a couple of months before you set the thing up. And so really trying to understand this variation in flow is really important, because you want to size it so that you can capture at least the most common storms, right? You may not get the Irenes. We'll never get the Irenes, right? But at least the storms that happen with great common, typical rain events, we want to make sure we're at least capturing those. The other thing is if you look at all these dots, these are all potentially individual outlets. They're all going into a ditch. We don't know yet what these estimated costs might be of implementing the BMP at the end of the tile. But if the costs are substantial, they've just gone up even more with each one of these being treated. And so the next step that we want to look at is, could we actually just put something in that ditch system? Rather than treating every outlet, treat the ditch system. And there's a fine line there, because some ditches are, I love Denise Smith's name, the stritch, the stream or the ditch. What is it, right? But you want to be sensitive to not getting into too large of a watershed. And again, I think understanding before you get overwhelmed, how much watershed you're managing and how much material you need to have, how much biological activity might be ongoing in that ditch. But anyways, that's the next place where we need to work, is trying to put a solution into a ditch and test it and see if it's successful, instead of doing individual one-off BMPs. And the ditch system might actually even be more maintenance-friendly, right? More accessible, maybe less challenge to rodents, and beavers may have other interests. I don't know which rodent might decide to take interest in what activity, but it may be an easier maintenance. So here's an example of, we're trying to do these trial BMPs, best management practices, versus what's reality. And I showed you that example of the concrete ledge septic tank is what that was that the water treatment residual media was put into. We did that so that we could clearly monitor that there was no influence of the soil and other factors. We were specifically testing what that treatment does, what that media does. But maybe in the end, the result is we should dig a trench and put burlap in it and put the media in and wrap it up, and it's not this hard infrastructure buried in the soil. Maybe you don't even need a burlap sack. I don't know. So, we definitely need to install a few of these systems at that lower structural level and see if they are effective and can be managed. The other is we're designing these systems for monitoring. It's a very different type of system than you would do for just managing a tile. And so when you're monitoring, it really matters where you put the infrastructure. We are sizing them to try and understand it, but with a more broad system, maybe you could do something more lengthwise in the buffer and really make it larger and longer. But for monitoring that's almost nearly impossible. And so just some of these alternatives that might be available can't really be tested. They really have to be field applied and then tested at the outlet to see how it goes. But again, one of the challenges is testing at the outlet. It's probably during those high flows that you want to test it, but you're never going to see the outlet, and you're not going to be able to test it. So really understanding the impact of these things, it's a really difficult place to be sampling and understanding. Excuse me. And then there's a lot of different field settings. Obviously when you're doing a field trial in one particular field, the outcome might not be the same in another field. And the reality is these tiles are throughout the landscape, especially in these heavier clay soils. They're not all the same site. They really are different. So some of the gaps that we have is, again, the types of practices that people do on field. So cover cropping, tillage, manure injection, so these management practices. As I said, we really don't understand the impact that they have on the outflow of the tile. And this is that diagram I told you to remember of the water control structure to show you how that might work before planting and after planting. And information that's needed is, we did this assessment up in the North Lake to look at how many presence or absence of tile drains, but we only did that in one small area. We need to look at that more broadly. And again, we're going to try and look at how can we map this, but at the very least, if that's something that's going to take time, we really should be looking at presence or absence and at least understanding in impaired watersheds, try and do some correlations between where tile is and what the impact or the challenges are in those watersheds. There are standpipes that come with tile drainage or cleanouts. In the RAPs, we've drafted to put a vegetative buffer and a manure setback from these, which was never required before. But they really can be a real source if there were nutrients to flow into them. And they typically are sort of at the low end of a field that may not have an outlet, sort of a bowl. They might have an upright in there. And so things do flow that way. And so hopefully there'll be more vegetative buffer. But we don't know how many there are of these. We don't know the potential impact of them. Yeah, I think I covered everything else. And well, modeling tools, there are some models that have looked at this, but they're not Vermont specific, and they're not really fine-tuned yet. And so there's a lot of active research in the modeling world going on to try and understand how to model subsurface drainage. Nitrogen, they've got a lot better handle on, but the phosphorus, there really is a field that's emerging right now at a pretty fast pace. So leading up to the final report, so again, summarize that we wrote an interim report that came out this year. Next legislative session, there's going to be a final report. And in that final report, there need to be recommendations to give to the legislature to chew on and work with the public to understand. And then they'll give us a summary of what we should include in the RAPs, which would be a revision in 2018. So that's the process that we're currently in phases of. But in this next year, the Basin Program, Lake Champlain Basin Program, has funded a literature review to look at similar things. So, there's a lot of literature, but what happens in Florida for tile drainage, for instance, is nowhere near applicable in all instances to what goes on here in Vermont. They're very different soils and also climate. But so we'll have a report. So I joked, there's the report of the nice nitrogen removal. Like, hopefully we'll have a phosphorus removal report. And it was interesting when I Googled that, actually. Nothing shows up to try and find a phosphorus tile drain report. It just isn't that high profile at this stage. And so we are really, leading some efforts here. Minnesota is doing some work. Wisconsin's doing some work. But again, they're also in more of these initial stages. So we just don't have a full picture yet of the information. But so the research literature review will focus on things that really do make sense to Vermont. So trying to tease out all that data and information from other literature reports that are not as applicable and putting something together that really helps us have a better understanding based on glaciated soils, rainfall, somewhere near what we get, those kinds of things. Quebec has some information, and certainly we'll use some of that. They do have a different landscape as far as very, very flat and highly drained. But the other thing that goes along with this project is sampling 12 tile outlets in Jewett Brook. And one of the things that I think is really, I'm looking forward to the results on this part of the project is it's over the whole year. So, grab samples of tiles have been done for a while. When you have a management practice, say, where you put manure on and it rains right after, like I said, your logic tells you it will be higher. Mm-hmm. But what you don't know is in the scale of the entire year and the entire load of loss from that field, what was the contribution? And how does it compare to other things? Is it really the issue we really need to focus hard and fast on? Or is it something else on that farm that really is a bigger source and really is if a farmer's making a priority list of the things they got to do, where does this fall on that list? And we just don't know that. We don't know the annual loading. The TMDL for Lake Champlain does not give you a block saying that this much is from subsurface drainage. So, manage the farmsteads, manage the cropland, and manage the subsurface losses. We don't have that kind of breakout. And so this is going to help us understand of the load, for instance, going into St. Albans Bay, how much of it might potentially be coming from tile drainage, which then helps us weigh that and understanding how much really resource needs to be driven at this and the expediency of really getting this research and information. So Over the next year, we're going to create a matrix, is what I keep calling it, so that we can rank tiles. So this literature review will give this, the sampling of the 12 tiles will do this, and summation of any data that's available out there. We'll put it all together and try and come up with a matrix to basically prioritize tiles. My guess, this is all guess, is that the higher the soil test phosphorus levels are, the higher the potential losses might be out of the tile drainage. That seems like a factor that might come up as weighing high, right? And that's something where you can easily, across the board, look at fields and give that farmer that list that says, you know what, these 7 fields are higher than all the rest. Those are your priority fields that you really want to look at, either how you manage the crop, how you manage the nutrients, or implement a BMP if we can come up with a solution at the end of the tile, or both. So trying to prioritize them. Mapping, I mentioned we want to try and look nationally, internationally at what people have done to try and map tiles. We have looked at the data that we have available in Vermont, and we can pick up where tiles might be, but it is not solid data. We were talking about mapping impervious surfaces today and how great the data was able to be done in terms of high accuracy with that. There is not good high accuracy with the available resources right now for tile drainage, and so researching and getting more and understanding how much it costs, because I'm sure it's not a low-priced item to maybe fly an aerial view and allow us to understand just at least what do we need and how much is it going to cost. And then if you are familiar with the well driller rule, most of us, maybe not most of us, but many people have wells at home, and when someone comes and drills a well at your house, they have to be licensed and they have to report it to the state with a GPS location and depth and all kinds of information about the profile that they came through. And so, and gallons of water per minute, all this stuff, right? And so DEC and Ag are going to look at how does that program work, and what are the similarities that we can develop in creating something potentially for licensed tile installers. So the idea would be is that if you're going to be installing tile, and maybe I've just sort of made this up, but stormwater is a 3-acre threshold. Well, if you're draining more than 3 acres, why not then say that that's your threshold and you need to get a permit and you need to have a licensed tile installer do the work and report it to the agency. Equipment nowadays that is doing that type of tiling, where you're system tiling, they're GPS, they're really pretty high-tech stuff, so they can send the shape file in, if you're familiar with GIS, that you can keep a map up to date if we had the imagery and we're able to map it so that we can understand where it is. The other benefit of this is that when someone comes to report that they want to do, they ask for a request for a permit, DEC can do a nice assessment on, are there wetlands, are there natural resource features of concerns. You can really look at, is this a good site or not? And I think at this point most tile and drain installers are very well aware of many of these regulations, but it may catch some things that maybe aren't getting caught right now. But and find a better solution, right? And then the compliance tools. So if we make investments in mapping and we do create some kind of program to understand where future installations might go, we need better compliance tools to be able to understand if that someone didn't utilize that system. So aerial imagery or whatever tool it is, what do we do and how do we quickly identify it without time-consuming, sitting staring at a computer, trying to find things, right? So just a check and balance there. So again, we're working. One of the goals is that as we write this report and we go through all of these things that I talked about we're going to be working on over the next year to get input as we do all of this, because maybe there are things that we didn't think of yet that people think we should really be looking at and considering. The Secretary and Commissioner are going to figure out how to get a stakeholder group together that would be run between the two agencies to be able to get that input. And then, again, the outcome is our final report in 2017 with recommendations to go in the RAPs in the 2018. So that is my presentation. Thank you.
Thank you, Laura. So at this point, we can take any questions from people in the room and people who are watching online. You can send your questions through the chat, and we can ask them for you that way. So at this point, we'll just open it up for whoever has questions.
So it would seem that macro pore continuity and preferential flow paths seem to be a big problem for clay soils.
That's what it seems like. Yeah, there's definitely research that shows that.
It also seem to be the soils that would most benefit from tiling. So I'm wondering about, aside from site physical characteristics that you can't change, are there management techniques that could be applied on those sites as far as manure application and timing with forecasted precipitation events?
Yeah, so I should have mentioned one of the other things that's in the RAPs is that if you know there's imminent weather, and it's more about runoff to surface water that because you can visually see that manure moves off site, that can be a violation now, and it's very clear that so if you're out applying manure, and then, this kind of came from the Irene thing, people out there spreading manure ahead of something that we all knew was going to happen. So to say, you can't do that.
Also, I'm wondering about outreach and education and conventional wisdom in agriculture regarding spreading before rain events to soak in.
Yeah. I mean, I think the challenge is that's what our logic says. I can tell you I've seen results that show the opposite.
Well, that's what I mean. It's combating that conventional wisdom that's not necessarily reflecting research and how to change practices that are long-standing because this is what Dad did and Grandpa did, something like that. And I think that would be a challenge, certainly.
Yeah, so like I said, in the Midwest, they're looking at, do they do some kind of other light tillage on these no-till lands just to help break some of that up? Some people have looked at, do they do more deeper subsurface tillage every once in a while to try and break these up? Our conventional wisdom was less tillage means better soil productivity, but is it also then leading to these larger cracks? Drier spells, bigger cracks, obviously, so climate sector certainly plays a variable in there. I think you really, it's hard to know exactly how and best to manage it. And given that these government has promoted this, and now we've got to figure out basically how do we address it. I think we're trying to do the best we can with research. And again, if that phosphorus index that is a tool that's used can outline some of that subsurface drainage and what it does, just so you know, for the phosphorus index, it may say your soil test level of phosphorus is somewhat high, your erosion risk is high. It could say no manure on that field. But that's how that tool works. It tells you sort of where you should be in terms of application rates of nutrients to manage them on that site. And so by incorporating that in that tool, it'll help hopefully understand good management practices. But it utilizes modeling, and every site may be a little bit different. Yeah, go for it.
So I get a couple of large farmers in my community up in northern Vermont, the Missisquoi Delta, in the Missisquoi watershed, knocking on my door, asking about my best hay meadow, and telling me, we'd like to lease this from you, like to drain it and plant corn instead, plant corn in what's now a hay meadow. And I'm interested in what you can shed light on in terms of relationship between implementation of new tile drainage and other changes in field practices. When I look at what's happening in the Missisquoi River watershed, not universally, but pretty overwhelmingly, new tile drainage is tied to conversion of pasture land that's not getting nutrient inputs into hayland, where you can spread liquid manure, or conversion of hayland into corn. And so I think there's a question here of is there any way that, what are the effects of that on water quality and TMDL goals? Do you have data on that?
So that's one of the things. So there's a technical advisory committee in the Lake Champlain Basin program, and that's definitely one of the topics that we've discussed, and it is in that literature review contract, which is basically to look at what does the overall land use change impact? What's the result of that? Does tile actually drive a change? And so that's something we want to look at because the trend right now in dairy economics is as a family farm centralizes more, it is more successful. And so farther away farms that might become part of the land base, maybe not the production areas, moving hay is much heavier, and you do it multiple times a year, multiple cuts. The economics corn is a better farther distance crop from the homestead. And so you can put all the pieces together to understand the economics of why the change is happening, but to quantify it is what we're hoping that report will come up with, some sense of getting some information about it, because there isn't really good land use, land cover data. There is, farmers do report data to Farm Service Agency if they have crop insurance, but that goes to Fort Collins, and I've tried to request it. It's a challenge. It's not, but hopefully some of this information and data will get compiled so that we can understand that. But I think that the real thing is understanding the solutions that we can put in place to try and manage that. One of the things, we've got a hay site that is in edgefield monitoring, and the numbers were astronomical after a rain event, after manure, because it doesn't go down, it goes over. And so, that's been a question to everybody too. Logic tells you that corn might be more impactful because you have more erosion potential. It's visibly clear that the soil surface is exposed, but the soluble surface runoff may not be the same. But if it's going through the tile, it may not be, it may be. And so we don't have these comparison understandings to know what's the right management to tell a farm, like, this is how to do it the best. I know that didn't help you, but
Other questions?
You're obviously looking at soluble phosphorus, but what about consideration of other labile constituents like fecal coliform, or things that could move really quickly off a field, like in maybe much faster than SRP would?
Yeah, we haven't incorporated that when most of these are USDA studies, and that is not one of the requirements, and there's only funding for the requirements in there, because they're more looking at nutrient. But there's also, DEC does sampling for E. coli, and there's TMDLs for some E. coli watersheds, and certainly that's something to correlate, right? If we were to look at some of these impaired watersheds, looking at the impaired E. coli watersheds and looking at the presence or absence, or if we can get good maps to see, is there a relationship between there's more tile here and raw manure going on the fields, that could be a source of addressing E. coli problems.
Imagine you'd get lots of different curves in time regarding different constituents moving off the fields as they are saturated, or how quickly they can move.
Yep.
I have a question. Do you think using LiDAR data would help you get that kind of aerial footage, like you were saying you needed to map where the tiles are?
My understanding from experts who've looked at looked at LiDAR, is that where there's a recent installation where you can see the ground disturbance is still present, the fine image is enough that you could see that there is tile there, but once it's flattened and cropped and
Then not really.
It's subsurface.
Huh. Okay.
My understanding, FSA disallows tiling above a wetland that may be impacted by that tiling. Aside from that, I haven't heard any other guidance or suggestions prior to any BMP installation or implementation on what is provided the farmer for installation, and then after installation and the BMPs that you guys determine, what guidance is there for decommissioning tiling?
And that's a whole area that we actually were just talking about this morning that we need to know more about. For instance, these watershed sizes, we were joking about the 30-acre field. Like, maybe we need something in the middle, right? Because the watershed size was too big. And so structurally, if someone's installing tile, what does that mean for how we advise potentially how they lay that tile? Because if it, just a rough number, like what if it were 8 acres is about the average size of a treatment system? So if you had to make sure that your system design was set up so that the watersheds for each one were about 8 acres, and you put a treatment system in with each system, or you can only, you can go back and look at some of these random tiles, and where they're less than 8 acres, it's applicable. So the industry has really looked into the drainage aspect of it, which you could do by testing soil moisture and crop productivity and really visual things. But because we haven't on that media side understood where's the break point for tile installation and ability for treatment, we don't have that research yet, specifically for phosphorus. And then as far as, obviously there's wetland regulations, there's all other regulations that are in place and will remain in place, and people shouldn't violate them if they're going to install tile drainage in places that is illegal to install tile drainage. That won't change. And again, if there were a permitting program, it would help pick up any of those if people just weren't aware. Sometimes people legitimately do not recognize that something is a wetland because it's adjacent to a wetland. It's just... So that is an area we definitely acknowledge between understanding better science and working with the industry to understand how tile is actually installed, how recommendations could be put in place to make it so that for the future there's more possibilities.
Okay. Yeah, I think, along with tracking installation, decommissioning should be a hot topic, because a lot of times I deal with a lot of wetlands, and a lot of times what I see are farmers wanting to convert fields that are either prior converted wetlands or converted wetlands. And if there are tiles present, it's hard to argue if a field lays fallow for 5 years and you have willows, etc., growing up. In places where tiling is installed and effectively installed, you could go back in 5 years, that field has been laying fallow, and you do a wetland delineation, and lo and behold, it's now an upland. You've now potentially converted permanently an entire wetland to a now upland system.
Well, so my understanding is that if you've got willows and shrubbery growing on anything that was previously in ag production, it is no longer in ag production. It's not growing food or fiber. So that would, if they were draining that and putting tile in, that would be a violation of wetland regulations. So they should not be doing that and changing it. But if it is actively farmed and they install tile, I would not doubt that it would not change the soil characteristics as far as a wetland designation, should it then go fallow into the future. Yeah.
All right, we have time for one more question, or we can wrap it up. Any last burning thoughts, comments? All right. Well, thank you again to Laura for coming and talking about the interim report, and thank you all for attending this Act 64 Brown Bag series.
Thank you.
Thank you.
All right.